Hello everyone, my name is Moin Kiani. My presentation is about electrical safety. I prepare concise explanation of electrical distribution safety rules and hazard awareness. Let's talk about some basics. What is the electrocution? Why it occurs? The logic behind this is the difference in electrical potential or voltage. The ground is considered as a zero potential, so electrons, when we touch the energized wires or something which is energized, the electrons use our body as a path through the zero potential, which is ground. You can see the logic in the picture top right. Let's talk about some misconceptions. Power distribution lines are safe because they are insulated. No, it's not like that. Insulation means applying material around the wire which is non-conductive. They are highly resistant to power, to prevent wires from having actually short circuits, having contact with conductors in proximity, but they are not actually considered as insulation for laymen or someone who touched them. No matter how they are actually weather protected from snow and rain, this is not considered as insulation. So they are not safe in general. Sometimes primary wires contains up to 21,000 volts of electricity based on the picture in the right bottom. Another misconception: it is safe to touch the birds on the power line wires. No, it's not. The reason why birds are safe on the wire is because the electricity cannot find their body as a representative path to the ground, which is zero electrical potential. But if you touch them, electricity can find this path, so there is a risk of electric shock or electrocution. Another misconception: ladders made of non-metallic materials are safe in order to work around the power lines. If they are wet, they consider as a medium conductive, so they are not resistant to electricity when they are wet. It is safe as long as there is no touch of power lines. No, it's not like that. Electricity can jump, especially in high voltage, actually in the shape of arc. Usually the safe distance, the minimum required for the safe distance is 10 feet. So you can see the arc electricity jumping in the picture bottom left. Common electrical hazard: electrical shock, faults, short circuits, fault currents. Let's talk about short circuits because it's very important in actually electrical distribution. It is simply a low resistance connection between the two conductors supplying electrical power to any circuits. You can see in the picture there is a current flow like a cycle. If the current flow find another conductive way, they actually use it to have another cycle. You can see the red cycle, red current. So it is considered as a short circuit. I explain later why it is important. Fault current. In an electric power system, a fault current is any abnormal electric current. For example, a short circuit is a fault in which current bypasses the normal load, which is called overload or overcurrent. Short circuits cause excessive heat. That's why important. This excessive heat cause actually fire, explosion, arc, damage to the equipment and wire of power lines, and consider as a risk for laymen. We should use some equipments like actually fuses, circuit breakers. They have the same function but like low voltage, but they're different because this is high voltage. Expulsion fuse, the one that we have in our bottom right, is used for actually to avoid short circuits. You can see the graph for the short circuits, what happened and what is this function of the fuse. If short circuits happen, current just increase to the peak. So it cause releasing excessive heat and have those consequences like fire and explosion. Fuse just absorb this excessive heat, absorb this current, absorbs this current and this heat, and the material inside of the fuse just actually melted and suppress the current from actually increasing. So when we use actually fuse, there is no peak for the current, so there is no consequence. But the current without fusing, you can see in a graph, the actually top right, is just increasing. Investigation and monitoring for hazard identification. We should actually know about the voltage of lines and equipment. We should actually monitor and investigate the present and condition of grounds and equipment groundings, actually conductors. Grounding in the high voltage is the same as low voltage. The logic behind this is just using a path more conductive for the electron to let them go through that path to the ground. Location of electrical circuits and equipment is very important. We should actually monitor and investigate them, and some activities may cause contact with the power lines, especially working with cranes and forklift, construction equipment in general. Actually, they have contact, that's a common actually incident. They have contact with overhead power lines. Tree trimming and fixing street lights, there are two others actually activities. And sometimes we have contact with underground power lines during the excavation actually activities. The clearance working distance is for the crane is 150 inches, and the line clearance distance is just 35 inches based on the pictures. Techniques for accident prevention. Staying away and maintaining the safe distance is the most important thing. Sometimes, especially for the workers who work with power lines, sometimes we use portable safety barriers in case for other workers in the work site. We should assume all power lines are energized, and we should identify the power lines with high voltage, and we should tell others about that by actually by having pre-job briefing sessions. We should take care of long objects, because that's another common incident in the work site. Usually, for example, when the cranes just pick up the long objects, there is a risk or hazard of actually having contact with actually power lines distribution. And another thing is just never touch the co-workers who's been actually electrocuted, because there is a risk of the thing that actually there is a still current in his or her body, so there is a risk of electrical shock. You should contact authorized person, qualified person with authority to actually de-energize the line and save the victim. Operation clearance for energized overhead lines, usually up to 50 volt is just 10. Minimum requirement distance is 10 feet based on OSHA, and if it is more than, it's 10 plus 0.4 inches for each 1000 volt. And in transit, if it is less than 50, there should be actually 4 feet, and if it is more than actually 345,000, it should be 16 inches. Trees cause to cut power sometimes. It looks simple to trim it, but usually all the time authorized personnel should trim the trees with a suitable equipment, because energized parts or power lines sometimes are hidden in the foliage of the trees. So we should investigate power lines prior to trim the trees. If you can't climb the trees, so the clearance distance of actually trimming should be 5, but if you cannot climb that, the clearance distance should be 3 feet. So, and this clearance distance is based on cycle length and tree species and growing condition, right of way limitation, and utility policies. We should use some equipments, personal protective equipments. As you can see in the picture, helmets, gloves should actually should be insulated through the electricity, and flame resistant clothing. And we should actually use, as a lineman, we should use rubber protective equipment. Usually linemen use hockey sticks to keep that minimum requirement of safe distance of 10 feet. Hockey sticks are poles made of an insulating material, because it should be considered themselves shouldn't be considered as a hazard, so there will be insulating materials. They have tools and fitting on the end, so that allows workers to manipulate energized conductor and equipment from the safety stand to actually repair something or replace something. And that's it. If you have any question, feel free to email me. I hope you find it informative.